Hello, Mr. Ashville here to take you through how to solve maximum mass calculations without using moles. So if you've never heard of what a mole is in chemistry, then don't worry, we can still work out these maximum mass questions without using them. So there's 3 steps that I'm going to follow for each of these to get the answers, so follow along. You should have had examples in the lesson that you can follow along with as well. So question 1 says butene reacts with steam to produce butanol. Calculate the maximum mass of butanol, which is C4H9OH, that can be produced when 1.4 kilograms of butene, C4H8, reacts with excess steam. Okay, so the first thing that I'm going to do is I'm going to underline my important molecules. So calculate the max mass of butanol. So I'm underlining that there, and I'll underline that in the equation. That can be produced when 1.4 kilograms of butene, C4H8, reacts with steam. Excess steam means I don't need to worry about it. So this is the important molecule, butene, and here it is, C4H8. Okay, it gives me the relative atomic masses, so I don't need to use my periodic table for this. If it didn't give me the masses, then I would look at my periodic table to find carbon, for example, is it here in group 4, and the mass of carbon is the number at the top, it's the larger number. But the question gives me the mass of all the atoms, so I can go on to the next bit, which is to work out the mass of this molecule and work out the relative formula mass of this molecule. So C4H8. I can work that out because I've got 4 carbons, each carbon weighs 12, so I've got 4 times 12, plus each hydrogen weighs 1, and I've got 8 hydrogens, so that's 8 times 1, gives me 4 times 12, so I'll use a calculator because I'm allowed to. 4 times 12 equals 48, plus 8 is 56. So how much does this butanol weigh? Well, that weighs 4 lots of carbon. Carbon's 12, so that's 4 times 12 plus 9 times 1 plus oxygen is 16, so that's 1 times 16 plus another 1 at the end for that hydrogen. So if I add all of those together, I'm going to get 4 times 12 is 48. Plus 9, plus 16, plus 1, gives me 74. Okay, so that's 1 done. Underline and add my relative formula masses. So number 2, I want to know what 1 gram of my reactant would make. So 1 gram of butene, or C4H8. I know that 56 grams of butene would make 74 grams of C4H9OH. So, how do I get this down to 1 gram? Well, 56 to 1, I divide by 56. So 74 divided by 56 gives me, so 74 divided by 56, 1.3214 blah blah blah. I'm not going to round that number up yet, I'll round it up at the end of the question only. So my third step is to say, well, I haven't got 1 lot of butene, I have got 1.4 lots of butene. So I need 1.4 times that, 2142 blah blah blah. I've kept it in my calculator, it speeds it up, so that times 1.4 gives me 1.85 kilograms. So that is 1.85 kilograms of butanol. On to number 2. Okay, on to question 2. Iron ore contains iron oxide. Iron is extracted from iron oxide by heating the oxide with carbon. The formula for the iron oxide is Fe2O3. Calculate the maximum mass of iron that can be obtained from 240 tons of iron oxide. Okay, so I will underline my important bits from the question. Calculate the maximum mass of iron, there's iron, that can be obtained from 240 tons of iron oxide. Fe2O3. Right, to do this question I need to write out a balanced equation by myself. So it tells me iron oxide, which is Fe2O3, plus carbon, symbol for carbon is capital C, makes iron, which is Fe, plus CO2. Okay, I could work out this properly, but the main thing to see is that for every one of these molecules, which has 2 iron in it, I must have 2 iron over here. Okay, so I've got 2 iron on the left, I need 2 iron on the right. And I'm only working out that because I know that these are the important molecules in the equation, or the important substances. It hasn't asked me anything about carbon or carbon dioxide. Just adjust the focus. Better. Great. So I need to work out the RFM of each of these molecules now. So RFM of Fe2O3, that's going to be 56 times 2 plus 16 times 3. So 56 times 2 is 112 plus 16 times 3. So that gives me 160. 2 Fe, so to work that I need 2 times 56 is, I've done that there, 56 times 2 is 112. Right, so if I had 160 grams of Fe2O3, I would make 112 grams of iron. What if I had 1 gram of Fe2O3? How much iron would I make then? Well, to get to 1 gram, I divide that by 160, so I divide this by 160. So 112 divided by 160 gives me 0.7 grams. Okay, so in this example, I haven't got 1, I've got 240 of whatever the unit is. It says tons here. So I need 240 from there, multiplied by how much I'd make from 1 gram. So 0.7 times 240 times 0.7 gives me 168 tons. So I use whatever the unit is up here. I've said grams, but these questions are often in grams. Just use whatever the unit is that it wants in the answer. Okay. In a different electrolysis, molten sodium fluoride is decomposed. Calculate the maximum mass of sodium that could be formed from 168 grams of sodium fluoride. Right, even if you've no idea what that means, it's told you it's a maximum mass question. So I can still follow those 3 steps and get a brilliant answer. I'm just changing the focus again. There we go. So the first thing I'm going to do is underline the important bits of the question. So maximum mass of sodium, there's sodium, that could be formed from 168 grams of sodium fluoride. There's sodium fluoride. So I need to work out the RFM. RFM of sodium fluoride, and I've got 2 of those, so it's going to be 2 times sodium is 23. 2 lots of 23 plus fluorine is 19, which gives me 23 plus 19 times 2, 84. And then I've got 2 Na over here, so 2 times 23 gives me 46. Okay, so if I had 84 grams of sodium fluoride, that would give me 46 grams of sodium. I haven't got 84 grams of sodium fluoride. I've got, I'll just write these down. So how much would 1 gram of this give me? So 84 divided by 84 gives me 1. 46 divided by 84 gives me 46 divided by 84 gives me 0.5476 ... So final answer, I haven't got 1 gram of sodium fluoride, I've got 168 grams. So my final mass would be 168 grams times 0.5476 ... So that times 168 gives me 92. There you go. Easy peasy.